All right, Unit 4, Lesson 1, the GO section. We are asked to indicate whether the given value is a solution to the corresponding equation. And like we discussed in class, if the value is a solution to the equation, that means that when I substitute that value in the equation, that it is true. So there are two ways that you could do this. One way is that you could solve the equation. So like one method, if I take the equation 4a plus 3 equals negative 9, I could just solve it to figure out the solution. So I would get 4a equals negative 12, and then I would divide both sides by 4 to get that a is in fact negative 3. So I can see, yes, a is negative 3 is the only solution to the equation. Alternately, though, it's a really good skill to just test this by substitution. So what I mean is instead of solving the equation, just substitute negative 3 for a in the equation. So when I do that, 4 times negative 3, negative 12 plus 3, is that in fact negative 9? It is. So when I plug in or substitute negative 3 for a in the equation, if I arrive at a true statement, then I know, yes, that was a solution. I'm going to work through the rest of them using that second method because sometimes it's easier. All right, number 18. So I'm going to substitute 4/3 for x in the equation below. So 3/4 x. So that becomes 3/4 times 4/3 plus 1/2 equals 3/2. Well, 3/4 and 4/3, those are reciprocals, meaning their product is 1. But if you forgot, when we multiply fractions, we multiply the numerators and the denominators separately. But some way or another, I need to recognize that 12/12 is 1. Not only is 12/12 equal to 1, but I could also write that as 2/2. And the reason I may want to do that is that now I have common denominators. When I'm adding, I get common denominators and I get 3/2 equals 3/2. So yes, 4/3 is a solution because 2/2 plus 1/2 is indeed 3/2. All right, number 19, y equals 2. I'm going to substitute that for y. So 2.5 times 2 minus 10. We're going to see if that's equal to negative 5/10 or negative 0.5. Well, 2.5 times 2 is 5. And 5 minus 10, 5 minus 10 is negative 5. So that is not equal to negative 0.5. So to show that, we could just use the not equal to symbol, and the answer is no. Y equals 2 is not a solution. All right, number 20, z equals negative 5. I'm going to do sparkly pen. I never used this one. I'm going to substitute negative 5 for z. And notice that I see z in here twice. So I'm going to substitute negative 5 each time. So we get 2 is 5 minus 2. Oops, sorry. Sometimes the sparkly pen's hard to see. 5 minus 2 times negative 5. That equals 20 minus 2 times negative 5 minus 1. This one's a little harder. This is why I don't use the sparkly pen. It's kind of hard to see, but we've done a bunch of examples already, so just for fun here. Okay, so instead of distributing, I would go ahead and just do what is in the parentheses. So remember, we are evaluating, so we are following the order of operations when we evaluate. So 5 minus 2 times negative 5, I need to do the multiplication first. I could think of 2 times negative 5 as negative 10. I still have a 2 out there. On this side, I have a negative 5 minus 1, which becomes a negative 6. Over here, 5 minus negative 10, that's the same as 5 plus 10. So that is the positive number 15. over here, I've got to multiply. I'm going to think of that as a negative 2 times a negative 6, which would make that a positive 12 when I multiply. And let's see, I get 30 on the left. I get that that equals 32 on the right. And those are not the same. So our answer here should be no. This one was pretty tricky. So like if you wanted to, okay, the rainbow pen is driving me crazy. If you wanted to, we could go back through and actually solve this just to make sure. So I might distribute that 2 and get 10 minus 4z equals, distribute this negative 2, watch out for that subtraction there, 20 minus 2z plus 2. So I get 10 minus 4z equals 22 minus 2z when I combine my like terms there. Let's see, we could add 4z to both sides. I just started crossing my z's so they don't look like a 2. I'd have 10 equals 22 plus 2z. Subtract 22 from both sides, and that is what? Negative 12 equals 2z. So, oops, divide by 2. So the only solution to this equation would be negative 6, not negative 5. But we were kind of close with the negative 5. All right, I believe that is all of the Go questions. And we said, no, that last one is not a solution.